All right, hello everybody. Welcome. Let's do this. In this section of our pre-AP calculus course, we're on page 45, and we're going to be talking about the domain and range of certain types of functions. So what I want you to do is let's take a look at questions 1 to 6, and what I want you to do is with a pencil or something, try and find the domain of each of these functions, okay? And then we'll go over them together. So, pause the video and try and do it by yourself. And now if you want to see the solutions, let's look at the domain of this one here. Let's see. Always our domain are all the values of x that have a y value. So here, how far left can I go? I could go as far as -4, but I can't be -4. So I'm going to have a parentheses over here. And how far right can I go? Notice that I can keep going this way, and I can keep going right because I have an arrow here. So I can just keep going right. So this goes to positive infinity, and it's a parentheses here because here, remember, you can't be infinity. So you always have that parentheses here. If this was closed, then you have a bracket here at -4. When we talk about the range, how far down can you go? You could go as far as -infinity. But how high can you go? This looks like you can only go to 5. And this is an open parentheses here. Okay, let's look at the domain of this function. How far left can I go? It seems like I could go to -infinity because I have that arrow here saying that I could go to all the x values this way. But there is some sort of, you see, as I'm at -infinity, right? And I'm going this way, this way, this way, this way, this way. When I get to x equals 1, here I can't be 1. So what we need to do here is we need to have a 1 over here and a union 1 to positive infinity. Because here, there's a discontinuity at x equals 1 because there's an open hole. So we need the union to kind of connect these two sets to show the domain of this function. As for the range, how far down can I go? I can go to -infinity. And how far high can I go? It looks like I could go to positive infinity. All right, let's move on. Here, the domain, how far left can I go? It looks like I'm at -infinity, right? Because the arrow is just pointing this way, right? So I'm at -infinity, right? And now I'm going. Now let's see what happens here. At x equals 1, you're neither here or here, but you do have x equals 1. So you do have x equals 1. That's a check. And from x equals 1, your domain just goes to positive infinity. All right. Here, what's my range? How low can I go? It looks like I could only go to -3. And what's my range? What's the max range I could go? You see, I could go as high as positive infinity. All right, let's keep going. For this one, how far left can I go? For the domain, it looks like I could go to -infinity, right? But then what happens at x equals -1, right? X equals -1, something happens. You see, I don't have x equals -1. So x cannot equal -1 here. So I need to have -1 here, and I need a union to kind of bridge these two domain values from here. So at -1, can I keep going right? I can keep going to x equals 5. And this is an open parentheses. For the range of this function, how far low can I go? It looks like you would think it starts at -3, but if you look at this part of the piecewise function, you see how this is going to the left, so I could keep going to -infinity. So the range goes from -infinity, and what's the highest I can go? It looks like it's between 3 and 4, so let's just call it 3 1/2, and it's an open circle. Let's look it over here. The domain of this function, how far left can I go? I could go to -5, right? And it's an open circle, so we have a parentheses. And let's see, from negative 5, do I have negative 4? Yes. Do I have negative 3? Yes. Negative 2. At negative 1, I do have a y value for negative 1. So from here, it jumps to here, and it looks like it just goes to positive infinity. Okay? For the range, let's see, how far down can I go? It looks like I can go to just negative 3, so this is negative 3 over here, and notice that your y value can be negative 3. This is closed over here, so we need a bracket. And how high can it go? It looks like it hits all the values, right? There is no discontinuity, so it just goes to positive infinity. All right, let's look at this one. This one gets a little tricky. So here, how far left can I go? It looks like I could go to negative infinity, right? And then I could go to negative 5, negative 4, negative 3, negative 2. But when I get to negative 1, I do have a value, so I'm okay. And then here, there's this, what we call is an asymptote. And we're going to talk about that very soon. Here, x cannot be 2. So what we need to do is we need to make a bridge from negative infinity to 2, parentheses, right? And then we need the union. And then let's see, from 2 to 4, you see how x cannot be 4 because there's that hole over here. So we need 2 to 4, and then from 4 to infinity. 4 to infinity. And that's the domain. That was a tricky one. And what's the range for this function? It goes from negative infinity to, it looks like positive infinity. Okay? That was a lot of work for just the warm-up. But let's kind of move on with the remaining lesson. So here, determining the domain of a function analytically. Here, if I have some f of x equals c, for example, like if I have f of x equals 4. F of x equals 4 is just a horizontal line at y equals 4, and it just looks like this. What's the domain of this function? Take a second, pause the video, and try and figure these out by yourself. What are the domains of each of these functions, okay? The domain of this one, now if you want to see, it would be from negative infinity to infinity. This one would also be negative infinity to infinity. This one is negative infinity to infinity. And this one is also negative infinity to infinity, right? Because how far left can I go? I could go all the way left for all of these. And when I see, look, how far left can I go? Notice that it allows me to go left, right? It goes up. And I could do the same thing for the positive infinities. So we're done with the first page. All right, let's move on. Here, let's take a look at this. We have, given below are graphs of 3 different functions, and let's investigate them. Here, these have special names. If we look at this function over here, we have some rational function. Okay, remember a long time ago when we did this in Algebra 2, that if I have a polynomial over a polynomial, we consider it rational. This is a square root function because, you know, it's just, we have the square root. Here, this is called the cube root function because we have a 3 in front of the radicand, so it's taking the cubic root. And these are generally what the graphs look like. Here, what's the domain of this function? Let's take a look over here. Notice that at x equals 2, we have this kind of asymptote, right? So here, what this asymptote means is that at x equals 2, let's take a look at this. If we're at negative infinity, right? We start at negative infinity, and then we go, and then look, at x equals negative 4, we're okay. At x equals negative 3, we're okay. At x equals negative 2, let me zoom in a little bit. And let me do this. Okay, so you see how at x equals 2, you see how it doesn't reach x equals 2, it just kind of just goes down. And the same thing here, where at x equals 2, it just goes up over here. So it never, at x equals 2, there is no y value. And if there's no y value, and remember, that's what the definition of domain is. Definition of domain is all possible x values that have a given y value. So here, this goes to -2, right? I'm sorry, this should be -2. And then this should be union -2, right? So we're at -2, and then how far right can we go? We could go to 2. And here, you see there's an open circle at 2, so I don't have 2, and then I need to connect it from 2 to infinity. Okay? What's the domain of this function? How far left can I go? I could go to -infinity. All right, so from -infinity, I'm going this way, this way, this way, but I can only get to 5. And here, is it open or closed? You have a point here, so it's closed. Okay? For this one, what's the domain of this function? It's just -infinity to infinity. All right? Because, for this cube root function, we just have everything to the left and everything to the right. There are no open holes or anything. All right.